Well, hello. We're ready for Section 6 of Chapter 1. In Section 6, we're going to be solving quadratic equations. We're moving on from linear equations to quadratic equations, where instead of just getting one zero, you're going to begin to get two zeros. A quadratic equation could be exampled by the following. If you have some ball and you throw it up into the air, it's going to take on the shape, the path of the ball is going to take on the shape of a parabola. And the parabola is a graph of the quadratic equation. If the ball goes up in the air and it reaches its maximum value, it comes down and it hits the ground right there. That's when its height in terms of time is 0, where this is the time axis and this is the height axis. We call it the h of t axis, where t is your independent variable and your height is your dependent variable. We say that the height of the ball depends upon the time that it's been in the air. Now, we say that the ball has an initial speed of 60 feet per second. I'm going to give you an equation that provides the time when the ball hits the ground. And here it is. I'd like for you all to write it down. It's negative 12 t to the second power plus 60t plus 5 equals 0. That 5 there is its starting height. Because the highest power that you see is t squared, that means this is a quadratic equation. So instead of 1 0, you would get 2 zeros. Now sometimes the zeros aren't always practical. This leads us to our definition of a quadratic equation. It's any equation of the form ax squared plus bx plus c equals 0, where a cannot be 0. A cannot be 0, otherwise it wouldn't be a quadratic equation. Some examples are 3x squared minus 4x plus 7 equals c. Or equals 0, sorry. X squared minus 10 equals 0. That's an example that's missing the b term, or the linear term. Here's another one. X squared equals 16. That's an example where x squared is just set equal to the constant, i.e. the c term. Some non-examples would be like y equals 1/2 x plus 2. That's a linear, with the highest exponent is 1. That's a linear function. Or x cubed plus 2x squared plus 7 equals 0. That is a cubic function, and we'll talk more about those in Section 2. Now, quadratic equations have two roots, or another word for a root is a 0, or a solution. Some people even call them the x-intercept. It's any value that satisfies the equation. There are always two of them. Always. If the root is a real root, and what that means by real is not complex. It doesn't have an I in it. If it's a real root, then that will be the location where the graph touches the x-axis. Remember, the graph is a parabola. We said that here earlier. Parabolas can face up or they can face down. They can also face sideways, but we'll mess with those later. Okay, now let's get to the goods. We're going to start factoring these quadratic equations. That's method 1 of the 3 methods there are to solve quadratics. When you factor, you must be set equal to 0. Have to be, otherwise you can't factor. That is very, very important. You have to be set equal to 0 first. You can also save yourself some work by always looking for the GCF first. And make note that factoring only works sometimes. Sometimes. It only works if the solutions are rational. If the solutions are not rational, then factoring won't help you. Rational means that they're numbers that can be written as fractions. You might want to put that in your notes. The square root of 17 is not rational, but 3/4 is rational because it can be written as a fraction. The number 4 is rational because it can be written as 4 over 1. That's a rational number. But the square root of 17 is not rational. I is complex. It's not rational. Pi is irrational. Has to be a number that terminates or a number that repeats to be rational. Okay, let's do a few examples. Here's example number 1. Solve it by factoring. X squared plus 4x equals minus 12 equals 0. Go through your checklist. Is it set to 0? Yes. Is there a GCF? No, so we can't take that shortcut. We're going to do reverse FOIL. Set up your factors just like so and unfoil this quadratic equation. What multiplies to get 12 but subtracts to get 4? Let's see here. 12 and 1, no, that won't work. 4 and 3, no, that won't work. What about 6 and 2? Can we make a positive 4? Yeah, if the 6 is positive and the 2 is negative. How about x squared? Break him down to x times x. Well, it's x plus 6, x minus 2. You're not done until you set both of these factors to 0, just like so. Subtract 6, that's negative 6, and add 2, that's positive 2. Those are your two solutions to that quadratic equation. If you were to graph this, 1, 2, 3, 4, 5, 6, 1, 2, you would have a parabola that crosses the axes at negative 6 and 2. That's the approximate graph of this quadratic equation. I'm going to show you how to do that on the calculator in class. Save yourself a lot of time. Now this one was easy because the leading coefficient on x squared was a 1. When he's not a 1, it's not so easy. Alright, let's do a few more. So, let me get this out of the way. And let's do numero dos. It says x squared plus 2x minus 15 is 0. Factor. Now, I was nice to you again, wasn't I? Because I gave you a leading coefficient of 1. That means there's only one option to break down the third guy, x and x. Since it's set to 0, break down the last guy. What multiplies to get 15 but subtracts to 2? Only one option here. That's 5 and 3. To make the positive 2, the 5 has to be positive and the 3 has to be negative. So, when I unfoil the factors, I get x plus 5 and x minus 3. Solutions, just flip your signs, negative 5 and positive 3. Again, the parabola would cross at negative 5 and positive 3. Look at that. You can even give him a little face, make him happy. He's a happy parabola. Oh, it's cute. Okay, let's do something. Let's kick it up a notch. Let's do something just a little bit trickier. Here's example number 3. It says 3y minus 2 times the quantity y plus 4. Well, that looks like it's already factored. Well, I'm going to set it equal to negative 11. Uh-oh, what's wrong with this picture? Oh, Mr. Williams, you told me that it's always got to be set to 0, but this one's not. Plus, this side needs to be FOILed first before I can do anything. So do a little FOIL here. 3y times y is 3y squared. 3y times 4 is 12y. Negative 2 times y is negative 2y. Combine them, that's 10y. And negative 2 times 4 is negative 8. Now, bring over the 11 to combine like terms. That's plus 3. Now, hopefully this bad boy will factor. What we do, in this case, since the leading coefficient's not 1, you break down the first guy, 3y and y. You break down the last guy, 3 and 1, that's the only option. And you ask yourself, can I make 10y somehow, some way doing reverse FOIL. Can it happen? 10y, 10y, 10y. I call that the magic number. So this is what we do. Get ready for your reverse FOIL. And you start guessing and checking combinations of these numbers. So now you can either guess 3, 1 or 1, 3. But I'll give you a hint. The ones that you guess cannot have any factors in common. So don't guess 3, 1. Guess 1, 3. If you put a 3 with a 3, you're definitely going to be wrong. So we've guessed. Now we check. We check by doing our outers. 3 times 3. Well, that's just 9y. 9y. 1 times y is just y. Can you make 10y by adding them? Well, certainly, if he's plus and he's plus. Well, if they're both pluses, then these are both pluses. Dun, da, da, da. You just factored a quadratic equation where the leading coefficient was greater than 1. Congratulations. These are the tricky ones. You need to be able to guess and check, and you need to be able to do it quickly. You need to be like, boom, I'm super fast. That's what you need to be like. All right, this answer is -3. This answer is a fraction, -1/3. Sweet. So if you graphed this, it would cross at -3 and -1/3, which is kind of in here. Just kind of. And then you go, there's my parabola. It faces up. Put a happy face because he's just as happy as the last one. And dun, 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 there's your parabola. Congratulations. All right, friends. I have one more I want you to do by factoring. Are you ready? Let us get rid of this stuff. Rewind it if you have to. Number 4. Solve 6x squared plus 22x equals 8. Solve that. All right, well, problem. It's not set to what? Tell me. It's not set to 0. So let's get it set to 0. Problem number 2. There's a GCF. It's 2. Pull it out. That's 3x squared plus 11x minus 4. You didn't have to do that, but it makes your life easier, so why not? Now factor it. I got a 2 hanging out. I'm going to reverse FOIL. I could guess 3x and x. Now here, with the 4, I could guess 2 times 2 or 4 times 1. But remember, my magic number is not 22. What am I doing? My magic number is 11. I'm trying to make an 11. What's the fastest way to make 11? 3 times 2 and 2 times 1? Or 3 times 4 and 1 times 1? Oh, 3 times 4 is 12. That gets me really close to 11. So let's put a 4 out here and a 1 right here. Okay, here we go. 3 times 4 is 12. A pretty little bitty 12 right there. 1 times 1 is 1x. X, 12x. Can I make 11x? I sure can if the 12 is positive and the 1 is negative, which means he has to be negative, he has to be positive, and dun 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 dun, you just factored. X could be -4 or x could be 1/3. Those are the x-intercepts of that parabola. I'm not going to do the sketch on that one because we've sketched enough of them, but you get the deal. You get the picture. Sorry, though that's where the parabola would touch the x-axis. Got a little tongue-tied there for a second. All right, that's what I got for factoring. Let's move to method number 2. Here's method number 2, completing the square. Now, in completing the square, a must equal 1. If a is not 1, you have to divide through by a, and that can get rather cumbersome. Cumbersome means difficult. Completing the square works always. It always does. It'll never not work, but it's not always practical, okay? It works best if A is 1 and B is even. It works best if A is 1, the leading coefficient, and B, the linear coefficient, is an even number. Now I'm going to warm you up here a little bit and just give you this quadratic equation. X squared equals 9. If I said just solve that as quick as you can, you would say, okay, well just do this. Take the square root. And you say, okay, x is the square root of 9, which is 3. Wait a minute, I'm supposed to have two answers. Oh, that's right. The square root of 9 is only 3 sometimes. Sometimes it's negative 3. And there's your two solutions. Or I could even give you something like this. X minus 1 quantity squared equals 100. And you would say, okay, we'll just do that the same way. Take the square root here, the square root here. The square root of 100 is plus or minus 10. This and the squared go away, so I have x minus 1 equals positive 10 and x equals negative 10. So that means x could be 1 plus or minus 10. That means x could be 1 plus 10 is 11, and 1 minus 10 is negative 9. Okay, and you say, Mr. Williams, I've done all that before. Show me something I didn't know. Okay, smart people, so let's try this one. Here's number 7. Solve x squared plus 10x minus 11 equals 0. And you say, Mr. Williams, why are we doing this by completing the square? Dude, this one factors. I mean, look down here in the right-hand corner. I could put x plus 11, x minus 1, and I could solve that. X is negative 11 and x equal 1. And I could move on with my life, Mr. Williams. Why don't I just do this by factoring? Folks, that's not the point. I want you to solve it by completing the square. Alright, so here's the deal. Step 1. Scoot the c. What do I mean by that? I mean like get rid of the c. And here's the c. It's the negative 11. That negative 11, he's not working for us. So what we do is we say, get out of here, negative 11. You're not working for us. So we put him over there on the other side. Then, step 2, add half of b squared. That means take half of the b term, which the b term is 10. That's 5. And then square the 5. That's 25. So what I do here is I put a little box. And I say, okay, half of 10. The middle guy is 5. 5 squared is 25. But whatever I do to the left side, guess what? The 11 is jealous, so I got to do it to the right side. He also gets a 25. Everything's fair in math. Step 3, factor and simplify. Factor and let's say factor and solve. By the way, folks, if a had not been 1, I would have had to divide through by a first before I could do anything. Alright, so the left side factors to x plus 5 and x plus 5. But I'm just going to put x plus 5 squared. Take a little shortcut. The right side, 11 plus 25 is 36. Well, looky there. Now I can just do what I did on the last one. Square root this side. That's x plus 5, because that and that kill each other. Square root of 36 is plus or minus 6. Don't you dare just say 6. And solve. Pick up the 5 positive, drop it off negative. X could be 1 or negative 11. And looky there. We got the same answers by completing the square as we did by factoring. The point was, I just wanted you to go through the process of completing the square. Now, I want you to do another complete the square, but on this one, the difference is going to be is it won't factor no matter how badly you want it to. Remember, I told you factoring only works sometimes. So this one, notice, there's nothing that multiplies to get 7 and subtracts to get 12. You can't do it. So I can't factor it. I'm going to have to follow my complete the square steps. So step 1. Scoot that C. Say, get out of here, C. You're not working for us. Get him over there. That leaves a space. I put a box in the space. What goes in my box? 6 or 6 squared? That's right. I put 6 squared. That's 36. Uh-oh, my 7 is jealous. There he is. He's jealous. So guess what? I give him a 36 too. That way he's not sad. The left side factors to x minus, because that guy's minus, 6 quantity squared. If you don't believe me, then write out x minus 6 times x minus 6 and multiply it. The right side is 43. Now, take the square root here. take the square root here, cross those off, x minus 6 equals, now the square root of 43 is not very pretty. It's not very pretty at all. So you know what, I'm just going to leave it. Now, if it could break down, I have to break it down. Like the square root of 24, that becomes 2 radical 6 when you break it down. But the square root of 43 doesn't. So I'm done as long as I just add the 6 to both sides. Now, what does that look like if you graph it? Well, what those are irrational roots. They're nasty, nasty decimals. Square root of 43 is what? Gosh, 6 point something maybe. Maybe like 6.5 or 6.6. So my answers are probably x is about, I don't know, 12.6 and maybe negative 0.6 or so. You could just do those on your calculator to find out. But if you were to sketch the graph, the parabola would cross at those nasty decimals. I just want to make that clear. Now, I want you all to try a couple on your own without my help. Here's number 9. I want you to solve 2x squared plus 7x minus 3 by the method of your choice. The solutions are negative 1/2 and negative 3. Now, based off of those solutions, you should be able to determine, since they are rational, that this bad boy factors. Oh, that's supposed to say equals negative 3. This bad boy does factor. And since the leading coefficient is not a 1, I would factor it. And then also I want you to solve x squared plus 6x plus 7 equals 0. Now the solutions here are negative 3 plus or minus root 2. Based off those solutions, you should know that this guy does not factor because these are not rational, they're irrational. So I would use complete the square on that guy. So do those, pause the video right now, do those, make sure you get the solutions I got, and if you can't get them, ask me about them in class. Alright, we got one last method, and here it is. And this is everybody's favorite, the quadratic formula. It's a song on YouTube. Anyway, to use the quadratic formula, it's got to be set equal to 0. It's got to be set equal to 0. You got to know your ABCs. And the quadratic formula works always. It never will fail to give you your zeros. It looks like this. It goes x equals opposite of b plus or minus square root of b squared minus 4ac divided by 2a. Alright guys, I'm not going to charge you extra for that song, but I know you're impressed. That was the Notre Dame fight song, if nobody failed to, or if nobody realized it. Anyway, you can, for extra credit, I will let you derive the quadratic formula. In other words, show me where it comes from, mathematically speaking, but I won't help you with it. Okay, but I'll give you some extra credit if you can do that. The quadratic formula, and I just learned this past summer, is only about 100 years old. At least we've only been using it very long. And when you think about how old or how long cultures have been doing math, that's really not that old. The ancient Egyptians didn't know the quadratic formula. The Greeks didn't know the quadratic formula. The ancient Chinese, the Babylonians, the Hindus, none of them knew the quadratic formula until only about 100 years ago. Okay, so let's do an example. Let me just make this a little bit smaller. But I still want to be able to see the quadratic formula. Here's the example. This is example number 11. Solve, using the quadratic formula, 2x squared plus 7 equals 4x. Well, first things first, that's not even written in the right order. So let's do that. 2x squared, bring over the 4x negative, make sure it's in the middle, plus 7 equals 0. This is, now our A is 2, our B is negative 4, and our C is 7. By the way, if there's a GCF, pull it out to make your life easier. So here we go. The quadratic formula says x equals opposite of B. Well, the opposite of negative 4 is positive 4. So let's put positive 4 plus or minus square root of b squared. B squared. Well, negative 4 squared is positive 16. That b squared term will always be positive. Make your life easier by remembering that. Minus 4 times a times c. And c, or a is 2. Put it there. C is 7. Put it there. Divided by 2a, and a is 2. And now you just simplify. It's a matter of plugging and chugging, guys. Alright, so 4 plus or minus 16 minus 4 times 2 times 7 is 56. That's right. All over 4. And then you just simplify, clean it up. 16 minus 56 is negative 40 divided by 4. Uh-oh. Got a negative inside here. What's it do? Oh, these roots are complex. You pull that out, now it's an I. Uh-oh. What about the 40? You can break it down. That's really 4 times 10. Square root of 4 is 2, so I got 4 plus or minus. Pull out the 2. It sits with the I. 10 is the bum. He stays in jail. And then you can even break him down by crossing out or by dividing him and him by 2. Notice, don't divide the 10 because that's not really a 10. It's the square root of 10. Final answer, 2 plus or minus I root 10 over 2. And then if you want, you can even split that apart. 2 over 2 would just be 1 plus or minus root 10 over 2i. That's the way that you'll see the answer in the book. Okay. Now notice, these are complex roots. That means this parabola, if you graphed it, would never touch the x-axis. I want you to circle the answer there and put the fact that these are complex roots. That means the parabola never touches the x-axis. They're not real roots. They're imaginary roots. Okay, so I've shown you the 3 methods. I want you to practice all those methods on your homework. You got questions? Let me know. I will make part 2, and then you can watch that one where I teach you just a little bit more about quadratics. You guys have a fun solving your quadratics. I'll talk to you later. I'm out.